We are group A26, and today in this video we are going to present about experiment 2, batch pack distillation. So the outline of our presentation will be the introduction, and the objectives will be presented by me, RABEA SALEH, and the methodology will be presented by PEI TING. Results will be presented by AMIRUL LUTTFI. Discussion will be presented by SYIFAA. Error and recommendation, conclusion will be presented by MB. So let's start with the introduction. So what is actually the batch distillation? Batch distillation is a process in which two liquids with different boiling points are heated, vaporized, and then cooled to obtain one of them in a higher concentration than the other. For example, if we have N-hexane with a boiling point of 69 degrees Celsius and N-heptane with a boiling point of 98 degrees Celsius, and this mixture is heated, we will have a vapor phase more concentrated with N-hexane because it has the lower boiling point, and the liquid phase will be more concentrated with N-heptane because it has the higher boiling point. And application of this, we can rely on the batch distillation unit in the industry because we can use it in eliminating impurities, or what we can call it purification. We can use it on removing water or drying, crystallization, recovering solvents, or even fractionating the complex mixtures. And one of the important application of this industry, of this unit, the batch pack distillation, when it's used for crude oil separation in the oil refinery, where you can separate the different hydrocarbon compounds depending on the difference in their boiling point. Now let's proceed with the component of the batch pack distillation. Simply, it consists of three main components: the reboiler, which boils the mixture, and the distillation column, and the condenser which condensing the vapor. Of this experiment, first, actually this experiment is done in two experiments. First thing is at total reflux, and the second thing is at constant reflux. What do we mean by total reflux is that the whole thing, the whole product is refluxed back to get a more purified product. First, the objectives of the batch distillation at total reflux is to determine the height equivalent theoretical place, and to determine the effect of the liquid and vapor on HETB. For the batch distillation at constant reflux, the main objective is to examine the change in the top and the bottom composition, and to carry out the mass balance calculation on the distillation unit. That's all from me. Now we'll proceed to the methodology, to my friend PEI TING.
Thank you, RABEA. I'm PEI TING, and I'll continue on the methodology part. Okay, first we'll prepare on the plot of refractive index versus composition. First, a set of mixture containing ethanol and water with a specific range of composition will be prepared. This will be the range for the volume of ethanol, and this will be the range of volume for water. And this is the apparatus we use to prepare the mixture. Okay, second, the readings of the Ri of the mixture will be recorded using this refractometer. And then we can plot a graph of Ri versus composition, which will then be used for other as a calibration curve for other experiments. Okay, we will proceed with the experiment. This will be the process flow diagram for our experiment. And next will be the real apparatus for our batch pack distillation unit. We will follow on with the first experiment, which is the batch distillation at total reflux. Okay, first the total reflux divider will be set to total reflux in order to prevent any distillate from escaping when starting up the distillation unit. Then the heater will first set to 100%, then follow on with 80, 60, 40 and lastly 20% accordingly. This will be the unit to set the heater percentage. The samples will then be collected, the distillate and the bottom product will be collected to measure its refractive index, only when a stable condition is achieved. This will be where the bottom product will be collected, and this will be where the top product will be collected. We will continue with experiment 2, which is the batch distillation at constant reflux. Okay, first the reflux divider will be set to a reflux ratio of 1, which is reflux timer 5 seconds and distillate timer 5 seconds. The heater power will then be set to 70%, and the samples will then be collected for measuring a refractive index. Both bottom and top product will be collected to measure its refractive index. This step will be continued with an interval of 7 minutes for 42 minutes. Okay. Then the fourth steps will be the distillate flow rate will be measured. This is where you record the volume and time of the distillate to determine the flow rate. This will be the place where you record the volume and also the time to determine the flow rate. Next, the fifth the last one, at the end of the experiment, is reminded that the volume of liquid left in the revolver is measured and the volume of the distillate is collected. That's all from me. Now I'll call on my groupmate LUTTFI to continue with the result part. Thank you.
Okay, hi, Assalamualaikum. I am AMIRUL and thank you to PEI TING. I am sent to do the results. So basically, we are using water and ethanol. We mix it in portion. We make it into 30 samples. So as you can see, as we decrease the portion of water and increasing the ethanol, the refractive index is increasing. So we take this as a reference and we plot it into the graph. Next slide. Okay, with this graph we make a linear fit and we get the equation, which is y equal to 0.0261x plus 1.3342, which present y is a refractive index and x is a mole fraction of ethanol. For experiment 1, we are doing the batch distillation at total reflux. As we decreasing the heater power, the refractive index as well as the mole fraction for the distillate is increasing, but the bottom product, the refractive index and the mole fraction of the bottom product is decreasing. So the number of stages is from 2 to 1, which we can get by doing the McCarthy method. Moving on to the next slide. This is the graph of the HTP versus heater power. Okay, for experiment 2, we are doing the distillation at constant reflux with heater power 70%. The refractive index as well as the mole fraction of the distillate is increasing, and the refractive index of mole fraction for bottom product is decreasing. Okay, moving on to the next slide. This is the initial condition before we start the experiment. The reboiler volume is 15 liter and the composition is 0.485. And at the final condition, the reboiler volume is 13.2 liter and the composition is 0.388. And the distillate volume is 1.4 liter. Okay, this is the Rayleigh table. The function of the Rayleigh table is to get the moles of ethanol in the reboiler. So as the time goes on from 0 to 42 minutes, theoretically the moles of ethanol should be decreasing, but we got a fluctuation in the result. But with some further correction, we may get a better result than this. And this is the graph of 1 over y minus x against x. From this graph, we can get the area of the graph and can be related to get the mole of ethanol in reboiler. With that, I pass the floor to Ms. SYIFAA. Thank you.
Okay, hi, Assalamualaikum. My name is SYIFAA and I'll do the discussion part for our last experiment, which is batch distillation unit. So the first thing first, before we do the first part and the second part of the experiment, we prepare 13 samples of ethanol water mixture, which then will be used to obtain the calibration curve. The calibration curve is the equation of the calibration curve is as follows. The y-axis is the refractive index, where the x-axis will be the mole fraction. The first part of the experiment is that we did the distillation at total reflux. Total reflux means that all of the products that will be produced at the effluent stream will be recirculated back to the column, so no product will be formed. For this part of the experiment, we will determine the effect of HETP and the effect of liquid and vapor loading on the HETP. HETP will be calculated based on the equation as above. So as we adjust the heater power from 100% to 20% in decreasing order, we get that the HETP value will increase, which means increase the power, the HETP value should decrease as well. It should increase as well, which means that the efficiency will get slower as the power decreasing. This is because less heat is provided, which causes the efficiency to decreases. So the second part of the experiment is that the distillation at constant reflux. For this part of the experiment, we fix the heater power at 70%, and the reflux ratio is 1:1, which that the reflux timer is 5 seconds. So the flow will be going back to the column for 5 seconds, and for another 5 seconds it will go out to the product of the effluent. So we calculated the flow rates manually, and we got that from our observation the flow rates decreases as time goes by. The mole fraction of the distillate also increases, whereas the mole fraction of the bottom product will decreases with time. Theoretically, the HETP value will increases, which means that the efficiency will decreases with time. So I'll pass the floor to Ambi. Thank you.
Thank you, SYIFAA. Let me explain about error and recommendation of this experiment. We found some error in this experiment based on the results obtained. The first error will be parallax error. This is happened when we recorded any reading. The second will be heat loss to the surrounding. The system consists of glasses and many tubes. Although the glasses are thick, there is some heat loss to the surroundings. When we're taking the top and bottom product from the equipment, the temperature of the surrounding may affect the temperature of the sample. The third one will be evaporation of sample. Since the alcohol is volatile, the sample evaporates easily and this affects the mass balance calculation. The fourth error is time interval and overshoot the time. When we wait for 7 minutes interval to collect the samples, sometimes we overshoot the time and it exceeds 7 minutes. This is because of delayed steps occurred while waiting for the refractometer reading. Lastly, errors while measuring the flow rate. This is because we don't have digital flow rate in the equipment. Let me give some recommendation to avoid the errors in this experiment. Firstly, the refractometer should be available more than one. Moreover, take at least 3 readings and take the average to avoid equipment error. And the average took of distillate. In conclusion, 2 parts of experiment is done, which are batch distillation at total reflux and at constant reflux. The graph of refractive index versus mole fraction of ethanol was plotted and used as calibration curve. The total reflux condition is to determine the height of equivalent theoretical plates, which is known as HETP, and the effect of liquid and vapor loading on the HETP at total reflux. The number of theoretical plates decreases with the decrease in the heater power. As the heater power decreases, the mole fraction of distillate and bottom also decreases. This is because the lesser the heater power, the lesser the liquid and vapor loading on HETP. Next. Okay, for the constant reflux, we determine change in composition of the top and bottom and HETP over time in a batch distillation unit. Flow rate decreases as time proceeds and mole fraction of ethanol in the bottom product decreases, and hence the mole fraction of distillate increases with time. Number of theoretical stages decreases for each time interval, and this causes the HETP value to increase as well. In conclusion, the efficiency of batch distillation pack unit will decrease with time. That's all from us. Thank you.